This is Unit 2, Lesson 5, and in this lesson we're going to talk about solving and graphing absolute value equations and inequalities. We learned earlier in the unit that absolute value is the distance a number is from 0 on a number line. So we know that absolute value can never be negative because it's a distance. But when you're talking about equations, we have to think about these a little bit differently, because basically what we're going to have is we're going to have a portion of our equation that involves the variable within the absolute value symbol. And so we have to think about this a little backwards. We have to think about what could x be inside the absolute value to make the absolute value equal to 5. Well, if you think about that, if x is 5, we would get an absolute value of 5. And if x is negative 5, we would get an absolute value of 5. So there are potentially two answers to this equation. When we have an absolute value equation, we have to set what's between the absolute value equal to the number on the outside, and we also have to set it equal to the opposite of the number that's on the other side. If we do that, then we have both the potential answers that could be inside of that absolute value symbol. Okay? Now, if we have something like the absolute value of x equals negative 2, well, think about what that's saying. It's saying the absolute value of what number equals negative 2. Well, is that possible? Can there be a number inside the absolute value symbol that will give you a negative? It is not, because absolute value represents a distance, and distance can't be negative. So we can never have an absolute value equation that is equal to a negative number if all we have is the x on the left. Now, I'm going to show you some other ways that we could do these, or some other types of equations that they might give us where there's a negative here and we can get it to work, but we'll talk about that later, not quite yet. In this example, we have the absolute value of x plus 8 equals 10. Well, this one's a little bit different because you've got a little bit of math that can be done here, but essentially we're going to start it out the same way. We're going to take what's inside the absolute value symbol, x plus 8, and the first equation we're going to get is we're going to set it equal to the 10 that we had originally. And then the second one, we're going to set the x plus 8 equal to negative 10. So anytime we have an absolute value equation, we will set the absolute value equal to the positive of the number on the right, or the number that's by itself, and we will set the absolute value equal to the opposite of that. When we set up the equations, the two separate equations, we will drop the absolute value symbols because we've taken care of the absolute value when we set it equal to the 10 and its opposite. And then we just solve the equation. So I'm going to subtract 8. Subtract 8 here. And so the two answers are x equals 2 and x equals negative 18. Now, we don't tend to graph equations for absolute values. We will get into the graphing when we get into the inequalities. In this segment, we're going to talk about absolute value inequalities. And if you think about it, since we said that in an absolute value equation, we have two separate equations with two separate answers, that's going to set us up to have two separate inequalities with two separate answers. So that means when we have an absolute value inequality, we're going to either have an and or an or, because when we have two inequalities in one problem, remember, it's a compound inequality. So we have to understand how to interpret which ones are ands and which ones are ors. So I've got just a little thing up here for you to think about. If when you have just the inequality is greater than or equal or less than or equal to a number, when you've gotten just the inequality on one side by itself, and you're getting ready to set up your two separate inequalities, when you get to that point, if you have a less than or a less than equal to, when you set it up, you have to put an and in the middle. Now, I always tell my students that if you look at the less than inequality, when you turn it clockwise, if you turn that clockwise, it will look like an A, okay? The top of an A. That's how I remember it. If I turn it clockwise, it's the top of an A, I know it's an and. If I turn this one clockwise, it will be a V, not an A, okay? Not the top of an A, so I know that's an or, okay? So that's how I remember how to do that. But remember, before you can set up your two inequalities, the absolute value has to be completely by itself first. So now that you know which one is an and which one is an or, we can set up inequalities, absolute value inequalities, and solve them just like the compound inequalities. So once you've got them set up to solve them and to graph them, it's just like what we did in the last section with compound inequalities. Nothing there has changed at all. So the only new thing with this section is the setup. After that, it's all old stuff. So with this one, the absolute value is by itself. So I'm going to set up my two inequalities. I'm going to have 2x minus 2 is greater than or equal to 4. And then the second one is going to be 2x minus 2, and I have to make it negative 4. Now, think about what that does in an inequality. If I have changed a positive 4 to a negative 4, doesn't that mean I have multiplied by a negative, or I have divided by a negative? And if that's the case, I have to flip the second inequality around. So the first one is going to be very similar to what we started with. You're not going to change anything. But then in the second one, when you change that number on the right to its opposite, you also have to change the inequality, because changing something to its opposite is essentially the same as multiplying it by -1. And we know from inequalities that if we multiply by a negative, we have to flip the inequality around. So there's the setup. Now, when I started this out, it was a greater than symbol. So if I turn it clockwise, it's going to look like a V, not an A. So this one is an or. So I'm going to solve each side separately. So I've got 2x is greater than or equal to 6, and x is greater than or equal to 3. And then on this side, I've got 2x is less than or equal to -2, and x is less than or equal to -1. Notice here I do not flip the inequality around again because I divided by 2, not -2. Okay, we divided into a negative, not by a negative. So that's why we don't flip it there. And since this one is an or, we're going to graph on the number line. So I've got -1 over here, 3 on the right-hand side. At 3, it is a closed circle. To the right, it's an or, so I graph on the number line. It's a closed circle, shaded to the right. And then x is less than or equal to -1. It's a closed circle, shaded to the left. So there is my graph of that compound inequality. In the next one, notice my absolute value is not by itself here. So I have to get the absolute value completely by itself before I'm allowed to set up the two inequalities. To do that, I'm going to add 2 to both sides. So my new problem is 3x minus 12 is less than or equal to 6. And now that my absolute value is by itself, I can set it up. So if I do that, I'm going to have 3x minus 12 is less than or equal to 6. And then for my other inequality, I have 3x minus 12. I changed the 6 to a negative. And since I changed it to its opposite, I have to flip the inequality around. This one started as a less than. If I move it clockwise, it looks like an A, so this one is an and. So that's how we tell which one's which. I solve each of them separately, just like I did before. 3x is less than or equal to 18, and x is less than or equal to 6. And then here, 3x is greater than or equal to 6, and x is greater than or equal to 2. This one is an and. So when I do my initial graph, I'm going to graph above the number line. 2 goes on the left, 6 goes on the right. At 6, it's a closed circle. It's shaded to the left. At 2, it's a closed circle, and it's shaded to the right. My overlap is between the two solid dots. So my final answer is shading the two dots in between there. So that's how you solve an absolute value inequality. It becomes a compound inequality. I'll put a couple more up here and let you solve those on your own, and then I'll give you the answers to check. Here are 3 more examples of absolute value inequalities. I want you to copy them down, set them up, get them done on your own, pause the video, and then I'll come back with the answers in a few minutes. Here are the answers to those problems. I'm just going to go through a couple of highlights for you. The first thing I did here was get the 8 on the other side so that I just had the absolute value alone. I have to do that in order to be able to set up the 2 inequalities. My 2 inequalities are here. It's an OR because when I turn that clockwise, it looks like a V. Then I solve for each one. Notice here, when I divided by the negative, I flipped the inequality around. Same thing here, flipped it around. Since it's an OR, I graphed on the line, and my number line looks like this for my answer. In the next one, first I had to get the absolute value alone. I subtracted the 3 over, then I multiplied both sides by the -2. Make sure when you multiply by a negative, you flip the inequality around. Then I could set up my 2 separate inequalities. So I did the first one, the second one with the opposite sign. I solved both sides. Then since it's an and, I graphed above the line. And notice there is no overlap, so I get a null set. Now I do want to point out on this one is a little bit different. Sometimes if we have a negative here, like if we had a negative here and this was greater than or equal to, we cannot assume that it's going to be a null set because there may be some numbers that would work if this is greater than a negative number. But since this one is potentially saying what is in the absolute value is going to be